So, Leona, what do you have for us?
If we had an educational system which taught our students, our children, to be Prometheans, I think the ologies would actually disappear. Because this is the study of the human mind, which is now allocated to these different, the psychologies, the sociologies, and so on, would largely be encapsulated already in your study of science. And what I'd like to do is to take up this, the way that our education system works, first from the standpoint of the development of the nuclear age. And where I want to start is here. Some people might recognize it, most people probably will not, because you don't see it very often. This is actually the first periodic table. So this is the periodic table that was drafted by Mendeleev, by Dmitri Mendeleev. And it was a very amazing thing because prior to this, you did have a lot of people who were studying the different characteristics of elements. But an important thing about this periodic table is that it's not describing what things look like, but rather the relationship of everything to each other and the relationship based on action. Right, so these are from several experiments, the active power of each element. And therefore, he had a certain insight into something that was beyond, something that was more universal to matter, and therefore could place them in an order. Now, the important thing also is that you see also that there are these blank places. So next to calcium, there's a little line, a blank. There's a number there, but there's no letter. And there are several places along here. You'll see in this last column, there are 4 dashes and so on. And what these represent are elements which have not been discovered, but technically have by him. And they've never been seen. They've never been sensed in any way. And yet, they are known in principle to Mendeleev. Now, this is the periodic table as it is known today. And it's much more filled out. There are more elements that weren't on his table, most of which are beyond uranium. They're transuranic. The transuranic ones beyond 92, a large part of them, and for people who are alive today, who are young today, you may have heard, just 2 years ago, for example, we had 2 elements being discovered. So you have elements being discovered all the time, and they're generally part of the same age. In other words, they were produced in a similar way. They're really all products of the nuclear age. But even before then, most people don't know that there were 4 elements which are suburanic. They were pre-uranium. They were in Mendeleev's table and were still not discovered until the 30s and 40s. The first one of that bunch was technetium. So technetium actually means artificial, because this is something that, again, was not found in so-called nature. But because of our increased understanding of the atom, of the nucleus, and its power, and the important thing was the ability to transform. And then being able to, once we understood that atoms were able to be transformed and transform themselves, for example, in decay and other things, our ability to use that transformative process to actively transform materials and use that for our own purpose. And so, for example, technetium is used for medical purposes. Tens of millions of medical procedures annually that we use this material for. So this is a material we've produced. Now, it's not unnatural. The potential for it was not artificial in that sense. But this element would not exist in any substantial amount, and definitely not enough for our use, without human beings creating this. Without human beings going through that process of first understanding a natural process, and then wielding that understanding to change the universe. Same thing with astatine, 85. Another material, again, which, and this is a funny one, we haven't actually characterized its physical characteristics yet, because there hasn't been enough produced to be able to see its color and whether it's a metal and its structure and so on. And so again, non-describable to the six senses, and yet we are able to use this again for medical diagnoses. So these are. Oh, and one more I want to point out is promethium, aptly named, was one of these four. Promethium 61, named after Prometheus. These are all, and people knew this was a new age. And then I want to show one more thing, which is this. Only if you've ever seen it before already would you know what this is. But after we stepped into the nuclear age, which is our ability to understand that this new process entirely. Oh, let me step back one step, which is that the nuclear age had a couple of parallel moves. One was the development of the understanding of radioactivity and the understanding that that was a change in what we were considering as immutable elements. Two was Einstein's E equals mc squared. So matter, an underlying nature of what we considered what matter was. And then three was our continual increase of understanding of the cosmos. And so our understanding of the so-called filled space of which we collected as cosmic radiation and things like that was absolutely integral to this whole age that we consider the nuclear age. But during this time, we also found that each element, each chemical element, which still had the same, which had these characteristics that Mendeleev ordered, also had sometimes 5, sometimes even 10 or more even analogs, isotopes they called them, which is the same place. They had the same place in the chemical or chemically in that periodic table, yet they had completely different characteristics. So you had these different variations of lead. And a funny story is that, so lead is a decay product. So, for example, is one of the decay products. So, for example, thorium, if left long enough, will transform itself. And then that will transform itself, and so on, down a chain until it gets to lead. And for the longest time, for quite a while, this form of lead was, lead 208, was called thorium-D. And people knew after some investigation that this was called lead. I mean, that this was a form of lead, chemically. But we still called it thorium-D for a while because its kinship was much closer to thorium than it was to lead, even though you might call it lead, and it seems similar to it, but in a process, it was closer to lead, and it reminds me of the harmonic scale, for example. You know, in harmonic progression, the fifth, for example, would be closer in kinship than the second, for example. But we started to get a sense of this this process of transformation, and then during this, wielding that, for example, to use fission and fusion, as for example our discussion on using helium-3 as a fusion fuel. Now this table, it's very hard to see, but the black ones are stable elements. So many of them we previously had discovered.
What does the position mean? Like up, down, left, right? What
So,
does it represent?
To the right,
It's time.
no, to the right are actually neutrons.
Ah,
Increase in neutrons, and up is the increase in protons.
okay.
And so, in very, very, very small letters in here, you'll see that the elements are listed along the one edge, and then everything along one row are all of that element.
Very clear exposition.
But now the black ones are stable, which means that everything else is not. Everything else are constantly in transformation. Now the black ones also are in transformation, but at a very, very, very slow rate. And one more thing to point out is that the upper portion, which are elements mostly transuranic, post-uranium, are completely unstable. Now, one of the things to point out also is that technetium was the first one that we made, which has no stable isotopes. And this is important because it may have existed in some larger amount at some point, but because it transforms itself so quickly, it no longer exists. I think it's the longest half-life it has is a few million years. Now, a few million years sounds like a long time, but not in history. Not in
the history of the Earth, at least.
Not in the history of the Earth, right. The dinosaurs were 65 million years ago, so even between the dinosaurs and now, that would have disappeared. So these are things that were created by us, by human beings, as nature creates them. But also the purpose, created for the purpose of advancing mankind, and thus advancing the capability to make those advances. And so this is actually a very exciting and I think necessary arc for all students to understand, not just nuclear scientists or chemists, so-called, which is actually a very small percentage of the entire population. Now, I didn't bring these two books, but I was reading a few books to get a sense of some of this history, and realized that there are two very disparate ways of communicating this history. And one of them, so I had a book from 1958, and I read this book, and it was a very insightful book, but of course it goes to 1958, so There's a half a century of development that I had to catch up on. So then I picked up a book from 2003. Now, the first book starts off with the history of X-rays. It starts off with Rutherford. It starts off with our complete, this paradox that had come about in the beginning of the century, of the 20th century, that there seemed to be a violation of the laws, a violation of conservation of energy, for example, or conservation of matter, and so on. It began with all these paradoxes, which then launched an entire several generations into investigating a completely new world, basically, to us, a completely new world. And now, the second book that I picked up started with, there are 92 elements before uranium. Each of them has valence electrons, and, and so on. And it actually says in the preface that there are things in here which we could only explain by mathematics. And because we're not going to go through all the mathematics, there are certain things that I will point out which you will just have to swallow. Very explicitly. And
Sounds like MIT.
well, unfortunately, it's much further than just MIT. And the two things I want to point out is ask yourself two questions when you're reading a book that's, now both of these books assume that the reader is a beginner, is a novice. And so these are both books who are trying to take you through a subject you've never really approached. So, for example, the 2003 one saying, well, an atom has electrons and protons and so on. They both start as assuming that you know nothing. But the first question to ask is, what do these two authors think about your mind? In other words, who do they think they're talking to? So they both think that you don't know anything about the subject, but otherwise, who do they think they're talking to? And I'll just explicitly say that what the first one, the earlier one has thought or has assumed about your mind is that your mind is able to go through a discovery. And the second one assumes that you can't. The second one assumes not only that you can't, but that it does not need to consider the human mind as a subject of its investigation. Because as you see, a series of definitions like that assumes or leaves out the substance of science. Because remember, science really is the study of the human mind. You know, a lot of people say that science is the study of nature, but one, they leave out human beings as part of nature. But two, the principles that we discover, a lot of them existed prior to human beings discovering them. And so to say that science then is means that it's never new. But science really is our ability to both discover these principles and then use them to our means, to then discover more principles and to increase the power of not just human beings, but of those principles of the universe. So, okay, so that's one aspect of it, is leaving the human mind out. Mm-hmm. Now, the second question to ask yourself when picking up any of these, they're textbooks, I guess. They're textbooks or novice books, is to ask, what is the effect on the human mind of shaping your textbooks in this way.
Beautiful.
Right, what kind of population do you create when you do this? Now, one is this newer, modern, maybe more modern, so-called way of writing a textbook. Really creates somebody who is just learning something to be sort of covering the subject, right? Covering all the bases. But is that really what type of person we want to turn out into society? Or do you want to turn out someone into society who is intimately integrated into mankind as a whole, into that productive process, into that entire process of history, which includes past, present, and future, just as Mendeleev had history in his periodic table.
Excellent.
And so that's what there's much more to say, but really this is where it comes down to. It's not really just a form of style. And you know, there's all sorts of explanations of why you don't need to read the original works. You don't need to study history in these things. We don't have enough time. I've heard all these arguments. I mean, I went to college and got all these different arguments of why that wouldn't be necessary. Why would you want to learn all these mistakes of other people, right? These things are wrong now. We have these other things which are updated. But really, what are you telling this? What are you instilling into this student? It's a stagnation versus an incredible creation process, which you're putting this new human being into. So I'll stop there and
You realize what you've done in this presentation. You've presented, in particular to me, things that I knew, but you presented them in a way which shows a process of development and shows it in the proper terms and overcomes the exact accumulation of errors which are implicit in what the list of things, the sequence of things that you bring in chronically into consideration. This is one of the best kinds of pedagogy that I've ever heard in any classroom.
Well, they should be brought into the classroom.
Well, that's exactly what my thought is not bring it into the classroom alone, but to bring the classroom into the process of realizing that mission. Mm-hmm. And what you've laid out a scheme which gives the student in any university who's had some qualification really in this area, and they get their minds ordered in a way which makes sense to reality insofar as we know it.